In section 3.2, there are three main goals. The first is to solve basic two-step equations. That will be using reverse PEMDAS. The next will be to solve equations by combining like terms first. And then the last is to set up two-step equations to model real-world situations. If you have an equation with more than one step, you isolate the variable using reverse PEMDAS. So what this would mean is that if you have addition or subtraction first, you would undo it before you undid multiplication or division. If you look at our first example, x is being divided by 2 and being added by 5. So if you go in reverse PEMDAS, you would undo the addition before the division. So to get rid of the 5, I would minus 5 from both sides. I bring everything else straight down, including my equal sign. 11 minus 5 is 6. And over here we'd still have the x over 2. Now to get rid of x being divided by 2, you would multiply both sides by 2. Remember, your 2's would cancel. And you would end up with x equals 12. So you're going to look at what's bothering the variable and decide on the two operations. And then depending on what the two operations are, you would go in reverse PEMDAS. So you would undo either addition or subtraction first. Then you would undo multiplication or division. If there were exponents or parentheses, those would come last. Pause the video, try these three examples right here, and then press play when you're ready to check your answers. So you can see that over here, we got rid of the 9 because it's adding. Adding would get rid of before multiplication. Bring everything down, follow the process, you get x equals 3. Over here we got rid of the minus 4 before the 4 that was multiplying. Go through the process, you get y equals 5. And on this one, to get rid of the minus 7, you would add 7, bring down your z over 3, and then multiply by 3 to get z equals 18. So if we scroll down a little bit more, the first thing that we're going to do here is we're actually going to combine like terms. So if you look at your 7x minus 4x, you can actually combine those because they are like terms. So 7x minus 4x would be 3x. Then you just bring down your equals 21. And now you just solve like normal. Divide both sides by 3. X would equal 7. So again, pause the video. You're going to try these three examples here by combining like terms first. Press play when you're ready to check your answers. Take a look here. 4w plus 2w is 6w, and then divide both sides by 6. You get w equals 4. 8t minus 3t was 5t. Divide both sides by 5, you get t equals 7. And then on this one, I changed the minus to plus negative. So 5d plus negative 9d was actually negative 4d. So now you're dividing both sides by negative 4, and you get d equals 4. So in these examples, I'm actually going to highlight some keywords and phrases so we can translate this into an actual function first. So here I'm going to start with the output of a function. Well, we know that the output part of a function is y. Is translates to equals. 3 less than, don't forget that less than means minus, but it actually means to do minus in the opposite order, so it would be minus 3. And then 5 times the input is x. So our function is y equals 5x minus 3. And then it says find the input, so we're finding x when the output is 17. So what that's telling us is to replace y with 17. So now I have 17 equals 5x minus 3. Sorry, that's an equal sign. And I'm going to solve this like normal. So at this point I'm going to add 3 to both sides, because I'm going to undo subtraction before multiplication. I'm actually just going to bring this over here so I have more room. So 17 plus 3 is 20. And then on that side, be left with a 5. So then x would equal 4. So again, pause the video, press play when you're ready to check your answers. So here the output of a function, again, that's y is equals 5 more than 5 plus negative 2x. And if you solve using reverse PEMDAS, you end up with x equals negative 3. And you can kind of see the whole process here, and then I just brought it over to this side. And then here, the output y is 4 less than, so that's where that minus 4 comes from. 4 times the input is my 4x. Solve using reverse PEMDAS, you actually get x equals 7 over 4. If you said 1 3/4, that's fine. You really want to avoid decimals at this point because sometimes decimals aren't going to be exact. So we're going to leave it as 7/4. It's reduced. There's really no sense to change it back to a mixed number. You can, but it's just one extra step that you don't need. You might make a mistake. So here it talks about a scuba diver that's descending into deeper waters, and the pressure of the water on the scuba diver's body increases. The pressure at the surface of the water is 2,117 pounds per square foot, and the pressure increases at a rate of 64 pounds per square foot each foot the diver descends. So what's happening is at the surface of the water, if you can kind of picture it up here, as soon as he gets in the water, there's this much pressure on him, 2,117. And as he goes deeper and deeper, every foot that he goes down, another 64 pounds of pressure would be added to him. And it wants us to find the depth at which the diver experiences a pressure of 8,517 pounds per square foot. So the 8,517 is the total pressure on his body, and that's coming from the original 2117, but then he got added to that 64 pounds per foot. The thing that we don't know is the number of feet, and that's usually a good way. What it's asking you to find is usually we're going to let your variable equal. So over here I could say that x equals the number of feet the diver descends, because that's what I'm trying to find, so it makes sense. I don't know it. When I don't know something, I use a variable. So total pressure is going to come from the sum of the original pressure plus the 64 pounds per foot. Remember that that word each usually means to multiply each or per. Okay, so per square foot, each foot. So that means to multiply the 64 by the number of feet, which we've called x. So now I could just solve it like normal. So I'm going to subtract 2117 from both sides. Which would give me 0, 0, 6,400. So it came out nice and easy. Divide both sides by 64. X equals 100 feet. So if the diver descends 100 feet into the water, that's when he'll experience the pressure of 8,517 pounds per square foot. So for this problem down here with Kim and the job, I want you to set up an equation, so something that, an equation to represent the situation, just like up there in black. Make sure you identify a variable, and typically your variable is going to identify the thing that you don't know. So then set up and solve the equation. Pause the video, come back and press play when you're ready to check. So in this problem, the thing that we didn't know is how many hours she worked, so that's what our variable is going to stand for. We know that she makes $8 per hour, so 8 is going to multiply the number of hours, which we've called x. But then she also earned $13 in tips, so you just add on the 13 and her total was 53. Solve using reverse PEMDAS and you get that she worked a total of 5 hours, which makes sense. If you're making $8 per hour for 5 hours, that would get you $40, plus the 13 in tips would get you the 53.